So here's the big one. Are we alone in the universe? For literally centuries, that was a question for sci-fi, right? Pure fantasy. But not anymore. Right now, using some absolutely mind-blowing science, we are right on the edge of finding the answer. We're doing it by looking for the chemical signs of life on planets that are light years away. And you know what? It all kicks off with a really simple idea. Okay, to get how we do this, let me ask you a question that sounds, well, kind of impossible. Picture this. You're standing miles away from a house, it's dark, you can't see in the windows, you can't hear a sound. So how on earth could you know if someone's home? The answer is, well, it's really clever. You don't stare at the house itself. You look at the light that's shining through its curtains, right? Because the way that light gets just a little bit dimmer or changes color, that tells you a story. And believe it or not, that's exactly the trick astronomers are using to hunt for life on other worlds. So yeah, that light coming through the curtains, on a cosmic scale, that's our window. It's this amazing technique that lets us peek inside planets that we could never, ever hope to actually visit. Now, there's a fancy scientific name for this, of course. It's called Transmission Spectroscopy. I know, it sounds a little complicated, but the idea behind it is just beautiful. We're basically letting a planet's own atmosphere tell us its secrets just by watching what it does to the light from its star. All right, so how does this whole cosmic detective story even begin? Well, it all starts with a bit of luck, being in the right place at exactly the right time to see a planet's shadow. This whole thing hinges on a really special event called a transit. It's when, from our point of view, a distant planet, an exoplanet, passes right in front of its star. Now, this perfect lineup, it's pretty rare. It doesn't happen for most planets we see, but when it does, that's our moment. A little window of opportunity just opens right up. So how do we even spot one of these transits? Our super powerful telescopes are staring at these stars, just waiting for a tiny, tiny dip in the star's brightness. That little dip tells us, hey, there's a planet here. It helps us figure out how big it is, and this is the important part, it's the starting gun for our investigation. Okay, so during those few hours while the planet is passing by, something really incredible happens. The starlight doesn't just get blocked out. A teeny, tiny sliver of it takes a journey. You can really break this whole investigation down into 3 main steps. Step 1, the planet transits, making that shadow. Step 2, a bit of the starlight gets filtered through the planet's atmosphere. And step 3, we catch that filtered light here on Earth and we analyze the heck out of it. And here's the absolute key to everything. That planet's atmosphere, it's not just empty space. It's full of different gases. And as the starlight shines through it, those gases act like a filter. They soak up very specific colors of light. So the light that finally gets to us, well, it's got pieces missing. And those missing pieces, that's the clue. So once we've caught that light, the real forensic work begins. We've got our evidence, and now it's time to decode it and see what story it has to tell. What astronomers do is they take that starlight and they spread it all out into a full spectrum, like a prism making a rainbow. But this isn't a perfect rainbow. This cosmic rainbow has gaps in it, dark lines where certain colors are just gone. We call those absorption lines. And this is the brilliant part. Every single gas, whether it's oxygen or methane or water vapor, it absorbs light in its own unique pattern. So each one of those missing colors in our rainbow is like a chemical fingerprint. It tells us, without a doubt, exactly what gases are in that planet's atmosphere. Okay, so figuring out what gases are there is cool. But now we get to the really exciting part, the whole reason we're doing this, using those fingerprints to search for actual signs of life. These signs have a name. They're called biosignatures. And what they are chemicals that, at least based on everything we know from life here on Earth, are pretty much only made by living things. You could think of them, quite literally, as the breath of alien life. So what are the big ones we're looking for? Well, water vapor, for sure. That's kind of essential for life as we know it. But the real heavy hitters are gases like oxygen. On Earth, almost all of it comes from photosynthesis. Oxygen is super reactive. It doesn't just hang around. So if you find a ton of it, something has to be constantly making it. And then you've got methane, which tiny little microbes love to produce. But listen, if you remember one thing from all of this, let it be this. It is not about finding just one gas. that's not enough. The real smoking gun evidence for life, it's finding the right combination of gases, a mix that, chemically speaking, just has no business being there together. Yeah, take a look at this. If you find a planet with just oxygen, okay, maybe it's some weird geology. It's possible. But if you find a planet with lots of oxygen and lots of methane at the same time, whoa, that is a massive clue for life. And here's why. Those two gases, oxygen and methane, they destroy each other. They can't coexist. So to find both of them just hanging out together in large amounts, it means something is constantly pumping both of them out. And here on Earth, that something is biology. It's life. So this whole technique, transmission spectroscopy, it's not just some clever trick. It is launching a brand new age of discovery, a new chapter in our search for where we fit in the universe. Now, I gotta be clear, this is not easy stuff. The signals we're looking for from that atmosphere are unbelievably faint. We're talking parts per million faint. And you always have to worry about a false positive, where some weird rock chemistry is faking a sign of life. That's why this whole search depends on incredibly powerful tools, like the James Webb Space Telescope. I mean, this is literally what it was built to do. And with telescopes like Webb, we really have turned a corner. I think this quote just says it all perfectly. We are no longer just fantasizing about aliens. We are now catching their breath, light year by light year. It's not science fiction anymore. We are doing the science, right now. I mean, think about it. For the very first time in our entire history, we actually have the tools to find out if we're alone. The question isn't, can we look anymore? The question is, what are we going to find? So I'll leave you with this. What do you think that first undeniable sign of life is going to be?